Why does the universe always move toward what seems like chaos? Why can't we unmix coffee and cream or unshatter a broken glass? The answer lies in a profound concept: entropy. It governs everything around us, yet remains one of the most misunderstood ideas in physics. Today, we'll uncover its secrets and relevance to our lives. Entropy is everywhere, from the smallest atoms to the largest galaxies. But what exactly is it? At its core, entropy measures how energy spreads out in a system. Let's break it down with some simple examples. Imagine an ice cube in a glass of water. The ice absorbs heat from the water and melts, distributing energy evenly across the system. This increase in entropy makes the system more stable. Or think of heat in a room. It naturally spreads out, never clustering in one corner. Even the clutter on your desk is an example of entropy. Over time, systems naturally move toward more probable states, and often less ordered. Entropy is everywhere. It governs how energy flows, systems change, and even time moves forward. But despite its importance, many people misunderstand entropy as mere chaos. So, what is entropy really, and why does it matter? To understand entropy, we need to look back to the 19th century, when scientists like Rudolf Clausius and Ludwig Boltzmann uncovered a principle that would reshape our understanding of the physical world. Entropy was first introduced by Clausius in 1865 to describe the natural tendency of energy to disperse in a system. It became central to thermodynamics, helping scientists understand why heat flows from hot to cold and why no machine can be perfectly efficient. Ludwig Boltzmann gave entropy its mathematical foundation, showing that it's not about chaos but probability. When particles in a system can arrange themselves differently, the most probable state is greater entropy. A common misconception is that entropy equals disorder. While it's true that high entropy states often look disordered to us, entropy is actually about how energy is distributed. The more ways energy can be arranged, the higher the entropy. Imagine shuffling a deck of cards. The more you shuffle, the more random the arrangement becomes. That's entropy increasing. Not chaos, but the system moving toward its most probable state. Consider a cup of hot coffee cooling in a room. The heat energy disperses into the air, increasing entropy. This process is irreversible, so we don't see coffee heating itself back up spontaneously. Entropy is key to the arrow of time. In an isolated system, entropy always increases, which gives time its direction. This explains why we remember the past but not the future. For example, when a glass breaks, its shards scatter and energy disperses. While you can glue the pieces back together, the energy dispersal that occurred can't be undone. Even the life cycle of stars is governed by entropy. Energy disperses into space as they burn their fuel, driving the universe toward higher entropy. The concept of entropy reflects both the balance and change within creation. The laws of thermodynamics reveal a system of incredible precision, pointing to a universe with order and purpose. From rivers' flow to planets' orbit, entropy reminds us of the delicate interplay between order and transformation. It also inspires us as stewards of creation to work within these laws to innovate and thrive. While entropy shows us that energy disperses and systems evolve, it also challenges us to use our creativity and ingenuity to bring local order and meaning to the world around us. Entropy isn't just a cosmic principle, it's a part of everyday life. Your smartphone battery drains as energy disperses. Food spoils because chemical reactions naturally spread energy. Even the mess on your desk is a small-scale example of entropy at work. But while entropy increases naturally, we can reverse it locally by inputting energy, charging your phone, refrigerating food, or organizing your workspace. These actions fight entropy temporarily, but always at the cost of energy. Entropy is more than just a scientific concept. It's a lens to understand energy, change, and even time. It shapes the natural world, our technology, and our lives. Rather than seeing entropy as a force of inevitable decay, we can view it as part of a finely tuned system that inspires us to work with the laws of creation to innovate, sustain, and grow. What do you think about entropy? Does it inspire you or raise more questions? Please share your thoughts in the comments and check out our next video on how entropy shapes technology and innovation. Don't forget to subscribe to ENITECH for more explorations into the science shaping our world.